I would like to show you a technique using a package called benchmark.net, which you can use to kind of measure the performance of your algorithms. So let's get started. To give you an idea, I've already run this thing and I'll show you a report that I've already generated for what I'm going to show you. But I just wanted to show you that it can generate a report like this. So I have basically two methods. One is supposed to be slow and what is fast, and they're doing the same thing. You can see the slow method when run multiple times, the mean value is so much higher and the fast is so much lower. And what this program does for benchmarking is that it will run it through multiple times and kind of give you mean, error, and standard deviation. And based on those values, you can actually decide whether the optimizations you are making are good or not. So it's actually much better than just using time watch or something like that, stopwatch or something. So let's get started. So what you first have to do is obviously include that NuGet package benchmark.net, and you can use attributes portion, and you can decorate with an attribute such as benchmark to whatever method you want to optimize. So I am basically benchmarking two methods, slow and fast. So that's what I did. I put in these attributes. So they are in the class perf. All you have to do then is to say benchmarker runner dot run and you name of the class, and you should be able to run this benchmark and see how that goes. So let me, and to run this benchmark you have to do it in the release mode. So let me make sure I do it in the release mode. What I'm going to do is make a quick change, and since I already showed you what the results were with the sleep statement, I'm going to comment the sleep statement out. So what I have to do here is to build this again, and since it's in .NET Core, I will essentially build it first in the release mode. You have to do it in the release mode, and then I'm going to just run the benchmarker runner, and we should be able to see the new results. While the new results are being calculated and it's being running, I can actually show you certain other things that might be useful. So you can see essentially you can mark some things as global setups, attributes such as global setup. You can also mark it with attributes such as param, so you can run the benchmarking stuff for different parameters. Say, for example, here it is running for 1000 and 10,000, and you can get some kind of ASCII reports like this. It can also generate CSV, XML, JSON, and so on, and which you can actually do for various plottings or various reports. So there are a lot of different features. I have actually not tried so many of all these features, but I've tried some basic ones. One thing you can do is it does have a way to run it for .NET 4.7, .NET Core, and so on for various different environments. So you can also actually do that. So feel free to read some of these overview articles. They will actually show you a little bit more information as to how you can actually specify what kind of jobs you want to run. So here you can see it's running a CLR job or a mono job or a core job. Core job would be .NET Core. So you can actually decorate it with some different attributes as well. So feel free to learn this and more advanced features on your time. Let me see how this is going. So here you can see that it is running this .NET runner in multiple times. So it will be able to give you a good result of what happens if you run this methods in different environments for different time and all that. Right now I'm just running it on a Mac, so I'm just doing .NET Core. I don't have anything else on this PC. So but you can see that it does run this thing many different times to get the results, which is a fairly highly reliable way of determining whether whatever performance reporting you are doing or changes you are making is worthwhile or not. It actually also just generate logs, which can be very helpful if you're trying to debug some problem. Here, see, I was trying to run this benchmarking stuff for a debug build, and it says it's not optimized, so it won't be, it cannot run. So you have to have it in the release mode. So you can also see there are various other things that are doing. So it will basically, as you already know, that in .NET we have the JIT compiler. So usually for the first time, the JIT compiler will run and cache the code, and second time it runs, it usually is fast. So it actually does do some calculations to take into account that fact that that may be happening. So that's why you can go through some of these detailed reports as well when if you are going to do a little bit more deeper dive. But as you can see, it's a very systematic and elaborate way of calculating and benchmarking your algorithmic changes, and you're not really flying in the dark. You are actually being able to see what makes sense and do that instead of just doing things without really knowing uh, what's going on. So actually this is a CSV report, and you can open it in Excel or something like that. And it does generate logs for older logs and add some new logs, so you can delete older logs if you don't really are not interested in seeing them. I mean, here you can see it is starting the benchmarking default jobs. So it's starting it again in some different mode here. So it actually does take a little bit of time to run this, but once it is done, you can be pretty sure that the improvements you are making or not making are worthwhile or not. So you'll get pretty reliable mean numbers or standard deviation numbers and all that. So here you can see this is the output. It is printing for slow and fast, and the output should be the same because it's essentially the same algorithm doing the same thing. So it is actually printing the same results. So right now I'm just kind of waiting through to have this finished and see what the new results are like that, because you have taken out the sleep statement. Um, Here you can see I have a local function that is called to just compute the same thing, that going through this for loop and getting the sum. So it's the same way, but it uses tail recursion. So here you can see that it is calling this function in a recursive fashion. So it's a recursion, tail recursion. So this tail recursion can actually be optimized by .NET. So that was kind of surprising to me. I did expect the recursive version to take longer, but it looks like the compiler is pretty smart and the numbers are pretty much the same. So I will just wait a few minutes, a few seconds, I guess, for the results to show up so I can actually show you the new report. It is actually taking a little bit longer than I expected, but that's just how sometimes things can be. Okay, so let me see what else can it do. Here you can see they have also done some, so these are the methods they wanted to benchmark, so you can decorate with that and so on. It does support some other languages such as F Sharp and VB for .NET, but I usually don't use those. I only use C Sharp. And actually you can specify what kind of JIT do you want. This is kind of the latest JIT, RYU JIT. But if you want to specify a legacy JIT, there is a way to specify a legacy JIT as well. So let me refresh this report and see if it is still running. I guess it's still the old report, so it's still running. Yeah, so it's still running for a second. It does take actually quite a while to run, but once it is run, you have fairly accurate results. Just to reiterate, and if you are using .NET Core, to build, you can use this command build minus c release, and to run it, you can use this to run it in a release mode. So that should be fairly straightforward. Again, this benchmark runner is in this benchmark.net, and I guess for the using statement, you can use running. And here for this attributes, you can use benchmark.net.attributes. So let's just kind of wait and hang around and see if there's anything interesting in the logs while it's going on. I guess it's doing concurrent GC. It's using here right now. Overhead of JITting, it is looking at. I don't know if usually I'm not that interested in it. You can actually do some memory performance numbers as well from this. But for that, I would recommend reading the manual and doing that if you're interested in that. I was usually just interested in benchmarking the performance of just two algorithms and see if it really makes a difference, and not really do it in the right way. So okay, so this actually finally did finish, and let me see if the report is done. So you can see the report is all done, and so it's very surprising results. Between the difference between slow and fast is almost the same. So you can see that if you have tail recursion in .NET Core, the compiler is pretty smart and will optimize it very good. So thank you for watching this short screencast. I will add this to my website under Gore Associate and C# .NET benchmarking. And you have a great day.